Welcome to this talk on Spring Security. Actually, it was the GOTO conference who decided that on this unhackable track, they really wanted to have a talk on Spring Security, and they asked me to deliver it. So when they did, obviously I said yes, because I'm a sucker for these sort of things. But I was also wondering, this is not a Java conference, right? This is a general purpose developer conference, let alone a Spring conference. So what can I do to actually create a presentation or a talk on Spring Security that will be interesting for more than just people already in that ecosystem, in that space? So then I thought, I know it. I'm going to make videos of myself half naked, jumping off of cliffs. I'm going to present that. But then I realized, no, I'm not in the Agile track. I cannot actually do that. You can only do that if you're speaking on Agile. So what I decided to do instead is I'm going to focus on applying this one framework, Spring Security, to build layers of defense in your application. And hopefully, even if you're here and you don't really have a Java or Spring background, you will be able to still take away several important things and lessons learned in the things that you should consider when actually securing your application. However, if you are in fact working in this space of doing Java Spring, then obviously you should be able to learn a thing or two as well. So my name is Joris Kuipers. You can tweet using this handle. I work for Trifork, usually as a hands-on architect. I'm also doing some Spring trainings here and there. And especially in a security talk, right, it's important to establish a sense of authority so that you can all trust who I am. So why am I actually the guy that should be speaking on Spring Security? It turns out I actually have an author tag in one of the related code bases, so you can trust me. So the interesting thing about this conference and this track, this unhackable track, is that security is such a broad topic, right? And if you have attended any of the talks in this track already, or even if you have just visited the keynote, that should be quite obvious. What you see there is that there is the actual physical security, right? Preventing people from actually messing around with your hardware and accessing it. There is the network stack, making sure that things are properly secured there, that you have firewalls in place, et cetera, et cetera. There is the operating system level. And nowadays, it isn't even clear really what the operating system level is, right? Because that could mean a hypervisor. It could mean a minimal host for your Docker. It could be your Docker containers themselves. So Adrian Miat actually did a talk which was mostly concerned with that level today already. It's the middleware. It's the applications. And again, it's not even clear anymore nowadays what is middleware and what are applications, because all of those things are fluid and merging into one. And of course, there is the whole idea of making sure that you have policies governing certain changes and allowing for security in that way. So I want to make it very clear that this talk will focus on how to apply security just at the application level, which I think is a nice follow-up on what we've seen so far. Basically, what we're doing is we're going up the stack from hardware to middleware, to secure coding practices in Kevlin's talk, to actually applying security to your applications here. Because if you're thinking about like a typical web application, there's actually quite a lot of different layers in your application, so to speak, that need some form of protection. There is the browser to begin with, which if you think about what Kevlin just said in terms of Postel's law, like be liberal in what you accept, well, the browser is an excellent example of how that can lead to all sort of known security issues. So you probably need some protection in that space. Then there is the application itself, right? You might want to secure things at a URL level, saying certain sub-URLs can only be accessed by a certain type of people. You might have multi-tenancy requirements. You might have security requirements at the method level. You might have security access requirements at the data level, right? So there's many different layers that you need to provide protection for. And sometimes these things are really not directly related, right? How I actually tell my browser that I would really prefer this application to only use HTTPS and not be embedded in like a frame of some other application is very different than what I'm actually going to do to secure someone from calling a method in my application if it doesn't have the right role. But in many cases, a lot of those concerns and a lot of those policies that you will implement are actually additive. They will reinforce each other. And that's important because the idea that you're having multiple things adding on top of each other also implies that there might be actually some redundancy in there. And typically when we think about coding, we think that's a bad thing because we've all learned that we need to be dry, we shouldn't repeat ourselves, and things should be in a single place, and we're all applying clean coding. It turns out that actually, when it comes to applying security to your application, it's a good thing to have some redundancy in there. You don't want to rely on just a single level of defense, because there might be obviously an error in that level of defense. And then if a perpetrator, an attacker, actually manages to go through that, or even worse, and that's what typically happens, find a way to simply bypass that completely, well, then you're out in the open, right? So you want to have multiple layers of defense. Now, this is a concept, this defense in depth, that's actually quite broadly applicable. It comes out of the defense, actually, mostly the military defense, but it's broadly applicable to software and to systems as a whole, right? So defense in depth is something that applies to the things I mentioned earlier on, like your actual operating system level, your network level. But even within an application, it applies to multiple layers there as well. So that's actually what I'm going to address. I'm going to address this by explaining how to apply something like that using an open source framework, which is called Spring Security. This comes out the Spring portfolio of open source projects. It's a project that you can use to add security at the application layer level in a number of different ways. It supports common standards, things like basic or digest authentication, form-based authentication. It can integrate with LDAP. It can integrate with single sign-on solutions. It has support for things like OAuth, OAuth 2, et cetera, et cetera. So there's all of these standard things. And it's basically written in a way that you can use it within any Java web application. It doesn't actually have to be a Spring application, let alone something like a Spring MVC application. Spring Security is actually quite general purpose, and if you have something that's a servlet-based Java web application, you can plug it in. And one of the nice things about Spring Security is it works completely at the application level. So what does that mean? It means that it doesn't rely on something like an outside container to actually provide you with security functionality that you then somehow need to integrate with. Because that's the standard model that you get in a servlet-based Java web application. You can define that a user needs to be authenticated and have a certain role, but you cannot actually define how that happens. It's completely up to the application server to support your authentication mechanism or authentication mechanisms, because nowadays it's actually quite common for applications to have multiple there. And it's going to be really hard to take that same application and deploy it onto something else, because you will need to start all over again in figuring out how to actually get that stuff up and running in there. It becomes even worse if you need something custom. In my experience as an application architect, it's actually quite common that people have some weird legacy backend system that they use as their source of authentication, for example. If you need to hook up your application to that, then good luck getting a plugin deployed to the company WebSphere cluster in order to facilitate that, right? So with Spring Security, all of this is actually handled at the application level. And it's up to your application to handle its own security requirements. That means, first of all, that the application becomes completely portable, because it's not actually relying on any outside functionality provided by some container. But it also means that you are in full control. So it becomes actually quite easy to extend and adapt your application to custom authentication scenarios, custom authorization scenarios, et cetera, et cetera. Right. One thing that is important to realize is that Spring Security is a framework that assumes that your code itself can actually be trusted. Right? This is not a framework that will prevent you from using an old Apache Commons collection library that has known issues with deserialization that allows an attacker to do certain things. It has no protection against all of the bad coding practices that Kevlin actually was just talking about, and how to actually clean up your code so that the code itself actually becomes secure. This is not that type of framework. This is a framework that actually builds on top of that and says we need to functionally add security requirements to your application and allow basically users to be authenticated and then do authorization. So that's what this thing is. And when it comes to those two things, separating authentication and authorization is one of the strong points here. You want to be able to say, I don't really care if a user was authenticated by entering a username password, and then we look that up in our own user database, and we have some hashed passwords in there, or we authenticated against an external LDAP server, or maybe we were actually already authenticated using some single sign-on system, and we just want to hook into that. We don't really care how that happens. If we then want to define, okay, users that have that and that role can call a certain URL, or users that then belong to a certain organization, a certain tenant in our application, can only access the data that belongs to that same tenant, right? Those are completely different requirements. And Spring Security makes sure that they are, in fact, completely different, so you can change one without affecting the other one. It's basically all interceptor-based, because that is what application-level security is basically about. Someone is about to do something, and we want to secure that. So we want to prevent that from happening automatically, and we want to check, are there any security constraints defined for what this user is trying to do? And if so, is the user actually meeting those requirements? If so, okay, we'll allow him to execute his action, or we allow him to access the data that he wants to see or that he wants to change. If not, then we're going to prevent the user from doing that. So how this basically works is that everything that happens up in the web tier will just use standard servlet filters because they are a built-in interceptor mechanism that is provided by the servlet spec. Everything that happens below that is based on custom aspects, basically, which is just another form of doing interception for code, if you think about it. This whole thing is configured using a Fluent Java API. For those of you who have not been using Spring for a while or have just been reading on it a couple of years ago, yes, there used to be a lot of XML configuration. If you're really happy about XML, you can still use XML configuration. It's actually quite okay because there is a well-developed namespace for that. But in this presentation, I'm just going to show you the newer Java-based configuration DSL for this. So what does it actually take to get started with this framework? Well, basically, you need to add it as a dependency. You need to get some filter set up. I'm not actually going to bother showing you that. If you're using a framework like Spring Boot, it will actually happen automatically for you. And then you do a number of things. You're going to explain the framework. Well, where are my users going to come from? How am I going to perform authentication? It's going to be username, password, form-based authentication with my own database. Or is it going to be something using client-side certificates maybe because we're doing a B2B integration, whatever you have. Then we're going to configure some centralized authorization constraints. So we can say only these type of users are allowed to enter these type of sub-URLs in our application, and these methods can only call by, well, whatever. I'm going to show you in a moment. And then you might also have some decentralized authorization that you put directly in your code in the appropriate places. And that's basically it. So this is the typical way that you would set this up. So we have a configuration class here. It's extending some helper class. And this helper will give you a number of builders, basically, to configure the whole thing. Now, I'm not going to explain everything here, but the first thing that you see here is this Authentication Manager builder. As the name suggests, it allows you to configure something called an Authentication Manager. And I'm not going to talk much about authentication in this presentation. I'm going to focus on authorization. But the Authentication Manager basically allows you to configure how do I authenticate users. Am I going to support my own custom database? Am I going to integrate with an LDAP or an Active Directory? Am I going to use Kerberos, whatever you have? If you are storing your own users, which is actually quite common in many applications, you're probably going to end up configuring something called a user detail service, which is a really simple thing. You just give it a username when someone tries to log in, and the user detail service will return a user with the actual hash password for that user. And the framework can then check if someone is successfully logging in because password matches or if it isn't. There are tons of other ways to do this, but like I said, I'm not going to focus on the authentication part. I'm going to focus on the authorization part. And one of the first things you should probably do is you want to make sure that certain things are simply not secured. Because if someone is trying to access a static resource like downloading JavaScript, downloading pictures, downloading CSS, in many cases you want that to be accessible for everyone, right? You shouldn't have to be a logged-in user for that. So you can use this thing called the web security class to say there are certain URLs that I just want to ignore. And we're just using some end-like wildcard patterns here. Right? Very straightforward. And then we get to the actual meat of the authorization configuration, which says, well, for example, there are certain URLs that I want to restrict access to. So I'm going to say everything under admin, you have to be an admin user. For some other things having to do with projects, and if you want to do a post to that, so you're making a change, you probably have to be a project manager. For everything else, you just have to be logged in. We don't really care about the rest. Now, I'll explain this in more detail in a moment, but this gives you an idea of a really basic configuration for Spring Security. And the interesting thing is that with this, without doing anything else, there will be a whole lot of defaults set up for you. You will get all sorts of custom response headers added to your HTTP responses, for example, that will instruct your browser to operate in a more secure manner. Also, you're going to get built-in support for cross-site request forgery, which I will explain in a moment in more detail. And you're also going to get a default login page because we didn't actually specify one ourselves, but you typically do. So before going into doing custom configuration on authorization, I'd like to explain what these defaults are. First of all, because it's important to realize what this framework is doing for you when you're not actually configuring all of those things. And second of all, simply because I've noticed that a lot of application developers are not really aware of what they can actually do in terms of headers to instruct browsers to act in a more secure manner, right? So one of the things that Spring Security will do for you is that every request that you make that is not explicitly ignored, we will tell the browser not to cache the response. Because that could lead to a situation where someone goes to a computer, logs into a site, does some work involving seeing interesting data that should not be visible to anyone, then explicitly logging out, going away, and then someone else comes in, goes to the browser, clicks the back button, and it can actually see all of the old pages because the browser had client-side caching. That's a security risk, but in general, if you're building a web application, another website, and all of your content is going to be dynamic, the whole browser caching thing is just going to get in the way anyways. So what Spring Security is going to do by default for every URL that you have not told it to ignore, because obviously for static content you do want browser caching as much as possible, it's going to add these browser headers, which is basically all of the different ways that you can tell a modern browser to say, please, please stop caching all of this content. And a couple of years ago, if you were using HTTPS for a secured website, this wasn't even that important because most browsers would choose not to cache content served over HTTPS. But nowadays, everyone using HTTPS for everything, which is actually a really good thing. But that also means that browsers will now, at least by default, mostly cache all of the content served over HTTPS. Right? So you actually need this in order for them to not do that. Something else is content sniffing. So again, this is a great example of Postel's law gone bad. What browsers typically expect from a response is a header that tells the browser, you know, the stuff that I'm actually sending you is going to be HTML, or it's going to be JavaScript, or it's going to be a binary file and it's going to contain a PDF, or it's going to contain an Excel file, or whatever it is that the browser knows how to handle. But if that's missing, then there's a feature in the browser that your browser says, yeah, you know what, I'm just going to guess. I'm just going to look at what's coming in. It looks like JavaScript, so it must be JavaScript. And you can abuse this in a number of ways. So for example, there is the idea of a polyglot file. This is a file that is valid as different file types. So for example, you can construct a file that is a valid PostScript or PDF file, but it could also pass as an actual JavaScript file. And an attacker might be able to upload this file to your system and then have another user download it. And if your system is not going to explicitly say, this is going to be a file with this and this content type, your browser may start to guess. It may guess wrong because that file might actually be a valid JavaScript file. It will execute the JavaScript. This is something that you can tell the browser not to do. It does require, obviously, that your application should have the right content type in your response headers. And this is just good practice, right? As a developer, you should know how HTTP works, and you should always make sure that this is the case. And if it is, Spring Security is automatically going to add this header, telling the browser, I do not want you to start content sniffing, as that is called, to guess what the file type is. I'm going to tell you what it is, and you're going to believe me, and you're not going to try to figure it out for yourself. Another interesting one related to the HTTPS transport I was just talking about is something called HTTP Strict Transport Security, or HSTS. So there is an attack vector where you could have a website that is HTTPS only, like your bank, for example. And if you access it over HTTP, what that server will typically do is just send you a redirect back to tell your browser, you're not going to connect over plain HTTP, you're going to connect over HTTPS. And from there on out, all of your communication is going to be encrypted. But that first HTTP request that led to the redirect, that's actually vulnerable to a man-in-the-middle attack. There might be someone, especially if you're on an untrusted Wi-Fi network, something like that, that can actually sit between your browser and the server, intercepting that request, and then redirecting you to something else that they control. And you think you're going to the right website, but you're not. So what you can do is you can actually send a header after your browser makes an HTTPS request to tell the browser, next time you're going to try to access this application domain, make sure you do it over HTTPS directly. So even if the user would bookmark a banking website using plain HTTP as the schema, your browser is going to say, I'm not even going to make that request, I'm just going to do a secure request from the get-go, which prevents you against that man-in-the-middle attack. You can do this just for the domain. You can also do this for all subdomains, right, if you are connecting to something. And this is the way that this is enabled. There is a strict transport security header. You can set some options there. And this is what Spring Security will do by default, because Spring Security tries to be as secure as possible out of the box. So you don't have to configure anything to get this. That's actually interesting because this can go very wrong. I've worked for a media company in Amsterdam where we had built their system and we secured it with Spring Security. And after that, it was in production, running already a while, did great, but they wanted to have some additional authentication options. And specifically, they wanted to have federated authentication using SAML. So we added that, and then the SAML library said, well, the user is now trying to come in with a plain HTTP request rather than with an HTTPS request. I'm going to deny it. But they weren't. They were coming in through HTTPS, and it turned out that the load balancer was terminating the SSL connection, and it was not adding the right header to the request to tell the application, you know, this request was originally done over HTTPS. Now, we were only using HTTPS at the time to allow the user to log in with the username and password. The reason for that was simply that the rest of their application didn't support full HTTPS only at the time, because they had some ad network that could only serve up ads over plain HTTP. What we did when we found out that our SAML library was telling us it doesn't work, you're not doing a secure request, we went over to the networking maintenance guys and we said, you know, can you add this header for us whenever there is an HTTPS request, because then the application will be able to actually tell that we're making a request over HTTPS. And they said, yeah, sure, we do that. We tested it, worked great. I left there, and I came back a week later, and it turned out that by asking those network guys to do that in production, because after we tested on acceptance, we said, yeah, just go ahead and do it in production as well for when we deploy the federated login. We broke their entire website, and not actually just their website, everything running on their domain. Because it turned out that as soon as someone would log in over HTTPS now, automatically that header would be sent to the browser, and the browser would say, okay, if you tell me, then I'll just continue to make all requests over HTTPS now, including all of the requests to serve up the ads and all of the other content that could not actually be loaded over HTTPS, right? So think about it. If you are going to add something like Spring Security or something else that will have this default to your application, your web application itself may not support HTTPS only, but hopefully it will, because that should really be the default in 2017. But also, that same application domain might host other applications that are not under your control that may not, in fact, support HTTPS only, right? So if you want to do something, actually, I think this is not a great default. This is probably something that you should just configure at the web server or the load balancer level to add that header, because there you have made an informed decision that it's actually okay for your entire domain to do this, right? So keep that in mind. Some other things that Spring Security will do is it will prevent clickjacking attacks. What this is a way that your site will actually be projected over some other website in an invisible frame. So the user doesn't really see your application, he sees something else. But when he thinks he's clicking on a button, he might actually be clicking on something in your website where he's already logged in and doing something that he did not intend to do. That's called a clickjacking attack. And there is an easy way to prevent this by simply telling the browser, you know, this site can never be embedded inside of a frame. And that's what Spring Security will do by default using the XFrame options here. You can tune that, obviously. You can say, well, it cannot be embedded in a frame if it's running on a different domain, but it's actually okay in my own domain because I trust that one. You have some options there, but you can look them up. This is an interesting one. Not everyone may be familiar with what this is. This is called a reflected cross-site scripting attack, where basically the server is just sending back whatever the user passed in. It's as simple as that. But that means that if the user is tricked into clicking on some URL, that might contain some malicious JavaScript, that JavaScript could actually get executed by the server, sending back exactly that same thing. Now, browsers, by default, typically prevent you already from this. But what browsers will do, again, in a typical post-sales law fashion, is they'll try to be as nice as possible because they really want stuff to just work and not break. So what browsers will do by default is they will try to fix the content that gets sent back this way. And that's another attack factor. And it turns out that there are actually attacks that make use of a feature of the browser that will detect an attempt at a reflective cross-site scripting and then tries to fix it but fails to, and you're still screwed. So basically what Spring Security will do is it will tell your browser, just don't even try. Just block all of the content that looks like this malicious type of request. So there's other stuff you can do, but that's not enabled by default. For example, you can prevent something called, well, actually you can enable something called public key pinning. What this is doing is that your application is actually telling the browser, this domain will always use this particular SSL certificate. And if you try to go to this domain the next time, and you find a valid certificate, but it's not actually that certificate, oh, watch out, something is wrong. Now, this is not something that I would typically recommend you to enable by default, but there are definitely good use cases for this. Maybe you remember a couple of years ago, there were a lot of problems with Lenovo laptops, for example, in the consumer range, that were actually shipping with software that was injecting ads into the browser, and it was doing that by actually man-in-the-middling you with its own custom certificate. Then that certificate was leaked, and basically attackers could make any website look legit to everyone owning such a laptop. Right? This would actually prevent that attack from happening. And there's some other stuff, but this is basically the idea of headers, right? And this is just the browser part. We haven't even made it to the server yet. This is just telling the browser to behave in a more secure manner. So something else that will be enabled by default is CSRF Protection. Cross-site scripting request forgery, also known as session writing, which I think is a much better term because session writing describes exactly what this is. It's a way for an attacker to just ride along with a valid session that you have already. So you, as a logged-in user, will be tricked to go onto some malicious website, and that website will actually make a request to the website that you are already logged in. Somehow it will trick you into doing that, like showing you this really big button that says, win free money now, when you're actually clicking on that. Now, don't do that, but if you do, what will happen is your browser will make that request, and because it makes that request to that domain, it says, well, I have a valid session cookie already for that domain, so I'm just going to send off the session cookie, and as far as the server can tell, you really initiated this request, everything looks okay, so it will just execute your request, right? You just got tricked into doing this. And this is actually quite a common attack factor, which is why Spring Security prevents you against this type of attack by default. But you need to do something here. This is not just a matter of setting a browser header because your browser cannot know this. So the way to typically do this is to add a custom token to every web page that your application renders that contains something like a form that a user can then submit. And then when the user submits that form, what you're going to do is you're going to make sure that you explicitly send that token with the rest of the form. And then the server can check, and it says, yeah, that token is there. It's actually your token, looks legit. But if an attacker tries to do the same thing, they will never be able to create a fake site or a fake page that will also send that same token header because they don't know that token header, right? Because they cannot actually get that from the server. You have to be logged in order to get the token, and then you have to send it back. That's basically how this works. Now, one thing that's important here is that if you're using this, you should only be using this for state-changing operations. So you should be doing this for posts, for puts, for deletes. You should not be using this for gets. First of all, a get should be safe in general. That's how HTTP is designed to work. A get request should not actually change the state on the server. So tricking you into making a get request that I, as an attacker, cannot actually see the result of should be fine. More importantly, if you would include the token in a GET request, it would have to be part of the URL, because you cannot put it in like a form-encoded body, because that's not how GET requests work. So that allows token optionally to leak, and then you're back to square one, because, well, then an attacker might actually be able to obtain your token as well, and he can again trick you into forging a request. So basically, how Spring Security does this is that when you log in, next to your session and your session cookie, you will also get a session scope token. And you, as a developer, are responsible for including that in all of your web pages where you are including a form that will be posted or put or used, delete, basically, right? If it's plain HTML, it's going to be a post, but if it's going to be JavaScript, you have to think about these other verbs as well. This is the typical way to do that. Basically, the token value and the name of the token will be made available as request attributes. You can just include them. There will be libraries doing this for you, right? If you're using like the tag library from Spring, or you're using something like ThymeLeaf, it will all do this for you automatically. You don't even notice it, but the token will be there. There will be a hidden request parameter in the form. Now, this is nice if you're building an application that does server-side HTML rendering. Nowadays, a lot of people are actually just building single-page applications that just post JSON in the body of the request. They don't actually post form-encoded parameters. So that means that you cannot add another form-encoded hidden request parameter. So there is a solution for this, obviously. And by default, the way that this works, in Spring Security at least, is you configure something called a cookie CSRF token repository. What that does is instead of creating a token and storing it in the server in the session, it's just going to be another cookie that it sends to the client. However, when the client makes a request, we're not going to check the cookie value because, well, that's going to be sent automatically, so that's not to be trusted. We're just going to make sure that the JavaScript running in the single-page application will take the value from that cookie and then puts it in the request as a header. We can take the value from that request header, we can compare it to the value that was also sent by the browser in the cookie. So we don't actually have to remember anything on the server here, we're just comparing two values that the browser sent to us, and we're going to check if they're the same thing. The interesting thing here is an attacker cannot force your browser to actually read the value of that session CSRF token from the cookie, and then send it as a request header, because cookies are restricted to be read only by JavaScript that was served from the same domain, right? So this gives you still a pretty good protection against CSRF. If you're a security expert, you might actually argue that it's slightly less secure. In most cases, you won't actually care because this is going to provide sufficient protection against the common type of CSRF attack. So that's that. That is basically covering the whole thing from browser to server, right? So now we actually get onto the server and someone is actually trying to make a request. We've decided that this is probably a legit request. It is not an attacker who is trying to force a user to do something. So how are we going to secure that? And a very common way is to say we're going to have rules that are going to match certain URLs in our application. So we're going to map our URL structure onto some authorities. Those authorities are typically roles that you may assign to a user. And then that will check if you have access or not. So what that looked like in Spring Security is that inside of this method that gives you this HTTP security object, there is a method called Authorization Requests that gives you a builder to configure all of this URL-based security. So in this example, what we see is that first of all, we say everything starting with /admin, that should only be accessible for admin users. Right? So this is easy to do if you actually model your URLs based on the security roles that you have, because then this is a straightforward one-to-one mapping. Also, we're going to say if you're going to have a user that makes a post, so that is supposedly an unsafe, state-changing operation, to anything under /projects, well, he has to have the role of product manager. Right? In this case, because I wanted to fit this on a single slide, we're going to say for everything else, yeah, you just have to be an authenticated user. You have to be logged in. You cannot be anonymous. You cannot be a guest user, but we don't really care about the rest. Now, there are some limitations and some tricky things in using this approach, and especially in using this approach exclusively. So first of all, this might become bloated very quickly, especially if your URL structure doesn't actually mirror your authority or your role structure, but you're using some other way of mapping out URLs. Very quickly, your code will look like this. And this is like 1/3 of the overall configuration of an actual project I'm working on. So this can become very tedious to do maintenance on very quickly. Also, it can be tricky to get right, because there are some subtleties here. Ordering of rules actually matters. Most important one should go first. The matchers might actually be slightly different in behavior than what you're thinking, and I'll talk a bit more about it on the next slide. And really important is you need to have a catch-all in place here, right? That's a common security principle. If you haven't explicitly stated how something should be secured, that's probably just should be inaccessible, rather than being unsecured by default. So on the previous slide, I showed you the any request not authenticated as the last line. That says that at least the catch-all says, well, you should at least be logged in order to do something. If I haven't explicitly allowed you to do it before, as an anonymous user, then at least I require you to be authenticated. If you're actually strict about security, well, maybe you should be paranoid, right? Say, okay, my catch-all is actually going to be, I'm just going to deny all access. So that means that you have to explicitly state your security requirement for every URL. If that is a workable approach or not, very much depends on your application, so I'm not going to try to pretend to have an absolute truth here, but this is definitely something to consider. So what are the gotchas that I was talking about? Well, here you see an example where first we're saying if someone tries to go to the product inventory subdomain in our application, every URL starting with that, they have to be an admin, but for everything else under /products, they either have to be an admin, but regular user rights also suffice. Now, if someone would actually reverse these two lines, all of a sudden you have a big problem. Because now if someone actually comes in on /products/inventory/ delete the entire inventory.html, it would simply match the /project/** rule, and regular users would be allowed to do this. Now, if you literally exchange these two lines, you would probably notice, simply by reviewing the configuration, if your configuration looks like this, and one line is over there and the other one is over there, you're probably not going to notice this. Right? So be careful about this. Make sure that your more precise rules go first. Another thing is this one, and this is a particularly nasty one, because I've seen people trip up over this. If you're not using wildcards, and you're saying, okay, /product/delete, that's only accessible to admin users, that will be an exact match. So if someone literally goes to that URL, okay, it will work. But many web frameworks say, well, /product/delete, I'll consider that to be exactly the same resource as /products/delete/. But Spring Security doesn't. Spring Security says, yeah, if you have a trailing slash and I'm using an ad matcher, that's a different URL. So that is not secured. If an attacker simply adds a trailing slash and tries to do this, who knows what will happen? It's certainly not going to be this rule that will match. So hopefully you have a good catch-all somewhere else, but not in the URL matching. So there is an easy fix for this, and that is to not use the end matcher. It's to use something called an MVC matcher, because the rules of that matcher exactly match the way that Spring MVC handles request mapping. But if you're not using Spring MVC, if you're using something else, make sure to understand those rules and make sure that you encode them properly and test this, right? So one thing that this illustrates is that just relying on a single layer of security, just relying on URL level mapping, is actually quite tricky. So in many cases, what you want to do is, in addition to this, and not instead of this, but in addition to this, you want to use method level security as well. So this is something that you need to enable explicitly. I'm just showing it here for those of you who actually care about Spring Security. So there is an @enable global method security annotation. You can say, I want to enable these pre-post annotations. And if you enable this, what this will allow you to do is you can put an annotation on a method. For those of you not doing Java, that's just a little piece of metadata. And that @preauthorize can be used to specify a security expression. So in this case, we're going to say, in order to call this method, there must be a logged-in user, and the logged-in user must have the role of product manager. And if that is not the case, so either there is no logged-in user, or there is, but he doesn't have the required role, this method will not be called. But instead, a security-related exception will be thrown, and you can handle that by showing either an access denied page if the user was already logged in, or by showing a login page if the user wasn't even logged in to begin with, and you can just start the whole authentication process there. And there's much more that you can do with this. Particularly interesting feature, I think, is that this will allow you to access method parameters in your security constraints. So in this example, what I'm saying is, well, not alone do you have to have a particular role in order to call update product, also the actual product that you're trying to update here should have a company ID, and the company would be some type of tenant in this particular system, that matches the idea of the current user's company. So that means I can only update product that belong to my company. If I'm trying to update some other tenant's products, maybe to just lower their price so much that they will go bankrupt, or actually do it the opposite way, so they won't be selling anything, I won't be allowed to do that, because I will only be able to update products that belong to my own company. Now, similarly to pre-authorize, there's also a post-authorize, so this happens after the method executes, and you can do some check on what it returns. So very similarly, if we say we want to look up a project by ID, that ID itself, depending on how we implement our multi-tenancy, may not actually indicate if this is a product that belongs to the current company or not. So similar to the previous slide, what we can do here is we can say in a post-authorize, well, the object that was being returned, which is conveniently accessible under the name return object, must belong again to the same company as the current user. Right? So that's what these things allow you to do. And this is still pretty declarative. We just put an annotation on code. I can write an integration test that doesn't do anything with security, and these things will simply not be handled, so I don't have to worry about setting up fake users everywhere, for example, for testing purposes. But on the other hand, they are actually expressive enough that I can do all sorts of things. So there's a lot of built-in functions for this. So I showed you has role. You can check for multiple roles. You can check if anonymous. You can check if someone is simply a logged-in user or not. But obviously, you're going to end up having some custom constraints here, typically. Now, you could actually tell Spring Security, I want to add my own expressions directly. So you could have, I don't know, has whitelisted IP address as a function. It turns out that even though it's possible, it's not particularly easy. Fortunately, there is a really easy way to get exactly the same effect, because from one of those expressions, you can actually call a method simply on one of your Spring-managed objects. So if we have a service called authorization checks in this case, or auth checks, to make it fit on the slide, we can say pre-authorize and then say, okay, in order to add a report to the patient that I'm passing in here, I want to check if the current user actually has an active treatment relationship with this particular patient. So this would be in the domain of some medical record system, for example. And this makes it really easy to have custom security integrated in a declarative fashion in your application. So that's method level security. Now, if you really only care about roles, and you also really care about standards, well, because standards, you can use an at roles allowed annotation, which is a standard Java annotation. It's fully supported by Spring Security, although you have to add support for it explicitly by saying JSR 250 enabled is true, because that's the name of the specification that includes this annotation. But this will only allow you to say users should have a certain role and nothing else. So in general, I just forgo this completely, and I would advise you to just use the pre and post authorize for everything, because you can do role-based with that, but also so much more. Right? So that's declarative method level security. Now, in many cases, as you're working with this, you will find that you also want to do things programmatically. Probably not directly in your business logic, mixed with security code, but in some other environments, you do need to be able to write code that accesses the current user. And that's actually really easy to do, because you can always access the current user by looking it up. There's a method for that, and the way that this works, for those of you who actually know a little bit about Java, is that the current user is always stored in a thread local variable called a security context. So what we can do is we can look up this authentication object from there, and then in the authentication we will find the user, which could be any type of object that you have defined as being a user in your system. Spring Security is pretty flexible in that. And you can find some other things as well, like the name and the actual authorities that were assigned to this particular user. And you can do all sorts of things with this. So just some quick examples of why you might want to use this. Obviously for custom authorization, right? Maybe you have some custom security check and you cannot implement it easily with something I showed you already. Well, just implement it yourself and write the code that hooks in to all of the places where you need to have that check. But another one is to say, well, I want to make sure that as soon as I have a logged in user, I will be able to put that in the output of my logging so that I can always see what user or on behalf of what user we were trying to do something when we issue a log statement. That's a really common thing to do. Also, if you are in a multi-tenant system, so you have multiple organizations with their own users and their own data, it's actually really convenient if you can always access the current tenant. So you might want to extract that from the current user and make it available to your application somehow. You could auto-populate things like database columns, right? Actually, using other Spring frameworks, you will be able to do this automatically. But this will allow you to see whenever a change was being made to a certain piece of data, not only when it happened, but also by whom it was done. You could make sure that, because by default this thing is stored in a thread, if you're actually going to have worker threads doing other things asynchronously, but you still want to know on behalf of what user that happens, that you can actually propagate the security context. There's tons and tons of reasons for doing programmatic access. So use it where appropriate. Just make sure that you don't start mixing security code with all of your regular business logic code, because the whole point of the framework is to actually prevent you from having to do that in the first place. So let's quickly see how we're doing on time here. Okay, then I'm going to skip this one. There is support for something called access control lists. Now, I'll show you the first slide for this. The idea behind an access control list is that you're going to have security constraints that are completely defined directly on a item that you want to secure. So they're going to be completely outside of your regular application logic. File systems are a good example of this, where per file, I can actually say what users have what type of permissions on this particular file, right? And they might actually inherit that from a directory, et cetera, et cetera. That's an example of an access control list. You can do this with Spring Security. Thing is, this is not needed, in my experience, for most applications. As I said in the beginning, you can trust me. So if I say it's not actually needed, well, then we don't actually have to cover the support for this. So some other concerns. You can also tell Spring Security, oh, whenever a request comes in, it's on plain HTTP, you enforce the secure HTTPS redirect. So that's called a secure channel support. And HTTPS is important. Even if you don't actually care about the data in your application, you might have something like a public site, so you don't actually have anything you need to protect, so you feel that it's okay to do it over plain HTTP. It's probably not, because that's still, plain HTTP still gives you the possibility that an attacker might actually be able to intercept things in responses, for example, and serve up malicious content, like maybe malicious version of jQuery that we're going to serve up as JavaScript. So HTTPS everywhere is, in fact, a good idea, even if your data itself is not the thing that you're trying to protect. On the other hand, again, just like with the HSTS header, this is something that you may consider putting in your web server or load balancer, or instead of doing it at your application level. There is support for limiting concurrent sessions, seeing how often a user can actually log in parallel with the same account, which is especially interesting if you're charging for your content and have a paywall, right? You don't really want your subscription that a user buys to be shared with the whole friend and family and neighborhood. There is built-in support for limiting the amount of concurrent logins. You can even do it in a cluster as well. And finally, one thing I wanted to check is how many of you are actually storing users in your own application database with their hashed passwords? That's a considerable number of people, but that's also my experience. It's actually quite common to do this. Now, you probably know already that in order to do this, you shouldn't store plain text passwords. You should use hashes. What I still see, however, a lot is that people will just copy like 10-year-old blogs that advise you to use something like MD5 or SHA-based hashes, which are not intended for storing passwords. Maybe to make them more secure, you're adding a salt. Well, I can tell you one thing. If you're actually storing your passwords using an MD5 with a salt, you might as well just store them plain text, right? People with GPU-based hardware, they can actually do a brute force on this, trying millions and millions of passwords per second, and they will be able to crack most of your passwords really in no time. So make sure that you're using an algorithm that was actually intended for hashing passwords, and Spring Security has support for that out of the box. I'll skip this one. So, to conclude, basically what you're seeing is that with a framework like Spring Security, you can handle security at many different layers in your application. And it's actually important to think about all of those different layers, right? Security is not something that you implement in one place and you're done. You need to think about these things. So in order to do that, or when you actually do that, you will find that you get much more of a defense in depth approach. Now, this is just defense in depth at the application level. Right? If you're actually attending the track today, then hopefully at the end of the day, you will have also a bit more of an idea of what it means to have defense in depth at all of the layers, right? Including things like operating system, networking, your Dockers, and such. But I find that oftentimes people forget to actually think about the application itself. So it's really important that if you're using any security framework, that you know what it does for you, how it works, but also what it does by default. Right? As I explained, there are some actual dangerous defaults that might prevent your application or other applications running in the same domain from working correctly. So make sure that you read up on this and that at least one person on your team actually knows a little bit about what they're doing. And then maybe, well, You could become unhackable, or at least you can blame someone else up in that whole security stack for screwing up, and it won't be you as an application developer. Right. So with that, thanks for attending, and do we have time for questions? One question. Okay.